Hello, my name is Mark Holbert. I'm a catastrophist. Together with my colleague Kola here, we're going to present test video number 9, the chasm between words and symbols or words and numbers. It'll be on Caveat Mind YouTube channel, and it's also the test video appears on stored on my website, Catastrophic Thinking, EssentialConceptsInc.com. The summary here indicates that the first four videos will explain some of the underlying essential concepts that are used in catastrophic thinking. This 9th video acknowledges that our minds are not as well developed as we thought or as we think when it comes to words versus numbers. These 6 examples come from my developmental period of my mind. All 6 surprised me and were significant emotional developments for my mind. If you solve any of them, you are smarter than I was. At the end in the appendix, I have listed 12 references for your further delectation. I should warn you that my spouse is a mathematician. Now, some of these are listed at the video at the end. Otherwise, they're just basic catastrophe type books. How to think catastrophically is a framework, an approach to problems. The entire process, especially using the 12 elements of caveat, are to try to think clearly and be open-minded to the ideas of others. Policy formation is really what I'm getting at here, and to be flexible, we need to adapt to changing circumstances and train and develop your mind to think. There's the catastrophic thinking process, also listed on a poster available at the store on my website. This video is aimed to overcome the one pitfall we all share, that we think in words rather than symbols or numbers. We can never overcome this flaw, but we can be made aware of it. And here are 6 exercises to help you decide if indeed you are afflicted with this common mental pitfall. Number 1, implicit conditions. Here's a question. True or false? A square has 3 sides. There's a hint. And the answer is true. Did you read more into the proposition, like defined by, only, or just? Did you think the statement was false because of something you read into the literal statement? I can't help myself. Did you solve it by thinking outside the box? Actually, this is painful for me because in the 11th grade geometry class, Mr. Thorson gave us an exam and said you're to be thinking logically. And the question was, an octagon has 7 sides. And I answered false. One of my classmates, Gary Littauer, had answered true, because the octagon does have 7 sides. It also has 8, but that wasn't the question. The question was, does it have 7 sides? It does. Now, in my development as an intellectual, at that time I was pretty cowardly. I sat there quietly thinking, he's right. But if I speak up and defend him, it's going to cost me a point. So I sat there and let Mr. Thorson stand his ground that it was a false statement. But it was true. And I can't say that was the highest moment of my moral courage. 2, the path less traveled. How many seconds are in a year? Okay, the answer is 12. But you solve it this way, don't you? 60 seconds in a minute, 60 minutes in a day, 24 days in a 24 hours in a day, then 365 days in a year. So the seconds in a year would be a lot. But how did we default to the shortest time span? Why didn't we think about all the possibilities for the definition of the word seconds? January 2nd, February 2nd, different answer. Number 3, numerical conditioning. We are taught to recognize patterns in numbers. This one is really sad. What is a function of 1, 3, 5, 7? Well, obviously, it's odd numbers. What is a function that produces 5, 10, 15, 20, 25? It's addition by 5s. And now for the tough one. If the next number is not 32, what is it? And the sequence is 1, 2, 4, 8, 16. Not followed by 32, as we are all inclined to think. No, the answer came from Moser's circle. A mathematician named Jürgen Moser, 1928 to 1999, had too much time on his hands, and he came up with a geometric problem that produces a sequence that starts out 1, 2, 4, 8, 16. The problem is that within a circle, if the circle is divided into distinct areas by connecting all the points on the circle's circumference as points are added, then how many distinct areas are created? Well, let's see. Less than 2 points means 1 area. 2 points means 2 areas. 3 points means 4 areas. 4 points means 8 areas. Oh, okay, so far so good. But then try for 5, 6, and 7 points. 5 points divides a circle into 16 areas. 6 points divides a circle into 31 areas. 7 points divides a circle into 57 areas. Some others suggest the sequence continues at 62, depending on the formula. Moser said the reason he developed the puzzle was to teach students not to prematurely jump to conclusions based on preconceived notions. For everyone looking at this, you think powers of 2. And I always wonder if this was on the SAT and I missed it, because I would have. Number 4, here's a proof that 2 equals 1. It's from basic algebra, and in symbols, the logic is flawless. Let A equals B, then A squared equals AB, A times B, A squared plus A squared equals A squared plus AB, 2A squared equals A squared plus 2AB. Step 5, 2A squared minus 2AB, and then it goes on and on. What we're doing is creating a binomial expansion, and then through algebraic principles, reducing it down. And guess what? You get 2 times A squared minus AB equals 1 times A squared minus AB. Cancel out the A squared minus AB, and you're left with 2 equals 1. So you can look at that. If you figured it out, what lesson did you learn about your mind? If you haven't figured it out yet, the hint is to dispense with letters and substitute numbers for A and B. Since it's algebra, it works for any number. But let's let A equal 1, B equals 1, so that A equals B. Try it out. Okay, number 5. See in the other side. What common function in the financial world creates the following sequence? The 854 sequence. 85491763320. The answer: to solve this problem, you must make the leap and jump over the chasm. Convert the numbers to words. Now, when my wife posed this little puzzle to me, I was baffled for a long time. At some point, I wrote it down and then converted it to words, but I still didn't see it. So how slow and stupid was I? To save the marriage, she finally told me, further humiliating me. And then here's another last one. Number 6 is a riddle. Following riddle was spoken to me, and I wrote it down as: a field contains 31 sheep and 28 chickens. How many didn't? So what mistake did I make in writing it down so that the riddle could not be solved? There's some confusion between words and numbers. Okay? Jump the chasm. You can jump the chasm between the words and the numbers if you revise the riddle to say a field contains 31 sheep and 28 chickens. How many didn't? Well, there you go. Now you got it. Hopefully the viewer now has some sense of the built-in flaws and traps in their thinking and desire to learn more. Clear thinking begins with recognizing the pitfalls between translating words and numbers or symbols. Always begin your thinking process with this simple analysis. Is there a potential miscommunication involving words versus symbols, words versus numbers? You will find this very useful to understanding humor, riddles, archaeology, and policy formation. And then the key slides, there it is, the 854 function, I listed that. Prove 2 equals 1 so you can spend more time on it. The conclusion begins with translating and recognizing the pitfalls between words and numbers, and look for those miscommunications and you'll solve many, many problems. Now I have here 6 references: the moment of proof, mathematical fallacies and paradoxes, life by the numbers, how not to be wrong, number training for your mind, 0 to lazy 8, how to figure it, humble pie, published in the United States as When Math Goes Wrong in the Real World, and humble pie in Britain, it was called A Comedy of Errors. A mathematician reads the newspaper, rock breaks scissors, and that's one I've got here, I think. Mathematical thinking for those who hate math. Now, if you've got somebody in detention because they were rowdy, they hate math, and they don't like it, have them read this book. It's the easiest book I'm presenting, and yet it explains math to the math hater, and that could be somebody in detention. And then finally, The Magical Maze. Essential Concepts Inc. is a website. Please like and subscribe, especially subscribe. I need more subscribers to become essential to YouTube. And there's my trademark and copyright. And I'll end every video with a prayer for peace. Thank you.